This is a brief demonstration of the Forrest Manufacturing Model 204 vertical blade bandsaw. I've got other videos that go into all the details. This machine was specifically built to be included into an automated production line. So it's set up a little differently than normal. The basics on Model 204, this is a high-speed bandsaw running a blade speed of around 3,000 feet per minute. The blade is supported by 20-inch diameter wheels. We can run up to about a 1-inch wide blade on this machine, some wider, but please contact me before you do that. I'll leave this door open, I think. This saw is set up specifically for integrating into a conveyor system. So the end user has product they need to cut. This can be fed by conveyor belt and then material taken off from with a different conveyor belt. So this will be sandwiched between two conveyor belts or roller conveyors, I'm not sure which. To make life easier for them, this machine is lower than usual by about 6-8 inches. So the conveyor is going to be way down here. And if it looks like the cabinet's almost touching the ground, that's because it is. To allow for incorporating this machine into a centralized control system, we have an upgraded control cabinet. The standard 204 will ship with just a magnetic motor starter with an overload. This machine has a control panel. We're controlling pneumatic blade tensioning. Pneumatic blade tensioning has lots of advantages. It gives better control over blade tension, giving you better blade life and more accurate cuts. It also makes changing blades much faster and easier. In an automatic system or semi-automatic system where you don't have somebody attending or watching the blade all the time, if something happens, you want to know. So this means that the blade will always be correctly tensioned. The blade tension itself is controlled with a pressure regulator valve. The regulator valve controls the air pressure going into the blade tension cylinder. Blade tension cylinder is controlled here on the panel face. Tension detention switch. So you detension it, basically the upper wheel moves down. You can take the blade off, tension it back up. We do have some logic integrated in this machine. First off, when the blade is detensioned, saw won't run. Tension it up, saw on. Saw is running properly, you get the green light. We have a couple fault conditions. If you don't have correct air pressure, we have an air pressure sensing switch on the back side. If the air pressure isn't there, or say you just disconnect the air line, blade goes slack, flashing red light means what a flashing red light usually means. If the blade breaks, we have a sensor for that. The way we do that is we measure if this cylinder strokes all the way out. So I can simulate that. Detension of the blade, pull the blade off the wheel, retension the blade, travels all the way out, flashing red light. Put the blade back on the wheel, tension it up, all good. So this cabinet is set up, I've got local start-stop and tension detention controls. This is set up such that you can also have remote start and remote stop just with contacts. So normally closed contact wired into the system here can be used to stop it. Normally open can be used to start it. Fuse disconnect. We have here a magnetic motor starter with overload. And so we've got some extra contacts in here for the fault conditions. So if you want to have your PLC or other control system read any fault conditions or machine status, you can pick up the contacts off of here. Another nice feature of this machine, the blade drive motor is a 2-horsepower 3-phase brake motor. The brake is a spring apply magnetic relay. So anytime there is voltage applied to the motor, the brake releases and you can spin it up. When I hit the stop button or you get any fault condition, it stops really quick. Second, maybe 2 seconds for maintenance. So never touch the blade of an energized saw. I'm going to turn the disconnect off. For maintenance, We can release the brake manually. So right now, the brake's engaged, I can't turn it. I can release the brake manually down here. Allows me to turn the wheels. You can turn the brake back on like that, or when you start the system up again, it'll reset the brake release, the manual brake release. Guide post is adjustable. Release the locking screw. Raise the guide post as high as you need to clear your product. It does a couple things for you. First off, the unused or non-working portion of the blade here is guarded. Bandsaws being what they are, guarding the unused portion of the blade seems important. Then you also, by having this as low as possible, reduce the free, or what I call the working blade length. The shorter the blade distance between the guides is, the better it is for blade stability, cut quality, such and such. So that's the basics. We can do something like this, or we have the ability to integrate or modify just about all of our saws to work in automatic or continuous operation systems, integrate with PLCs. We have some of that capability in-house, or we're happy to work with you and your system. If you have any questions or like to discuss a specific application, please feel free to call or email us here at Forrest Manufacturing. Thank you for your time.